Apparently I didn't quite animate this correctly. I usually try to check, but I've been swamped lately, so that shouldn't exist yet. Let's start thinking about using the new keyword because we haven't, I guess builder was the first creational pattern that we went over, but we're going to start really thinking about how we construct objects and what we can do to construct very complicated objects. The builder pattern was the first one of those. It was discussing the ability to take the creation, break it down into components, and then combine those components together to create our objects. The factory pattern is going to be a little bit different, but what is the new keyword and what does it do for us? Yeah, uses a constructor and it needs to return an object, right? But it's not just any object, it's a concrete object. It cannot return an abstract object. It has to return something tangible to the computer, at least. It still fits inside of a computer, but it's the conceptual idea is it's tangible. Oh no. So we need the ability to make a concrete object. Needs to be instantiable in order to be able to get an object back. So you can't make a new shape because we don't really know what a shape is. It's an abstract idea, you can't instantiate it. Now, if you say a square with a side length, that's enough information to instantiate something. But in general, we don't have that. On the other hand, you may have an inheritance hierarchy and you don't know which concrete class within a hierarchy we want to instantiate until runtime. Does that make sense? The difference between compile time and runtime there? At compile time, you would write new whatever the concrete class is. But in the middle of running a program, you want to be able to get access to swapping in and out the different concrete classes when you use the new keyword at the same point in your code. So depending on some certain abstractions or certain stuff, for lack of a better word, you may want to use one or another different concrete class there. You end up with conditional blocks. If this condition, then instantiate this object. Else if this condition, instantiate this object, et cetera, et cetera. And if you have a really large inheritance hierarchy, those blocks can get really gross and long and convoluted, and we don't want them. So here at compile time, we make a new mallard duck. But now we have if picnic, then instantiate a mallard duck. Else if hunting, make a decoy duck. Else if in bathtub, make a rubber duck. So you have lots of different conditions that can instantiate different concrete subclasses of an inheritance hierarchy. So that's the start of our motivation. What's the issue with this? When we talk about overarching design of our classes and our objects and the code that we write, what main idea could we use to critique this code?
We have to wait until it runs before we know what we're building.
Yes, that's part of it. I mean, it will work, right? Though, like we can figure out we're only going to be in one of these conditions, so we will instantiate the right object. But what else? What happens if sometime down the line, we want to add a new kind of duck? Is this that duck's class? No. How many places could this if, else, if, else, if, else, if block be in your code? Is that only going to be in one place? Maybe. You have to go back and look at all of your code and say, where do I decide what type of duck I am instantiating? Whenever I add a new duck, you have to now go add another piece of that conditional wherever that code is done. And we've talked about extendability before. Whenever we come up with a new subclass, we want to just add that subclass and be done. We don't want to have to go back through code that we wrote and make changes to existing classes. That is kind of a lofty expectation. You're still going to have to do that at some point because things change, but you want to minimize how frequently you do it. So the answer is extendability. We'll need to open this code. We'll need to add more conditions to this code every time we add a new object into this hierarchy. So it's not extendable easily. You can also think of it as being coupled to the design. When you have this if-else block, if the design changes, then this code changes. You want to be able to swap out designs with the minimal amount of maintenance work to your code. So it's very easy for these large if-else blocks to appear in multiple places in your code. As that happens, maintenance becomes a problem. Whenever you want to update something, it's time-consuming to update it. Whenever you go change something, you may make a mistake. It may stop compiling. Even worse, there may be some kind of new runtime error that's associated with it. You may not get the condition right. You'll have to write some additional tests in a bunch of different classes to make sure that each new place that you added is functional. Hopefully you wrote some good tests before that now fail. If you didn't write good tests, you may not know there's a bug there until much later. Coming back to the new keyword. What are some limitations? We talked about the concrete object, but what are some limitations with the new keyword? This kind of has some overlap with the builder pattern that we were talking about. Yeah,
You have to know all the constructors when you make the new objects.
yeah. You need to know what the construction is going to look like, but it's also just a method, right? You don't get the power of a class with a single method. There's a design philosophy that we want to program to an interface rather than to an implementation. And whenever you use the new keyword and put logic in that constructor method, you're programming to an implementation. So it's really hard to program to an interface while using the new keyword by itself. If you write code to an interface, it's going to work with anything that inherits from that interface through polymorphism. If your code, on the other hand, depends on a concrete class, we have this concept of open for extension, but closed for modification. That's the open close principle that we've brought up a couple times. So it's not going to be closed for modification if we do this, if we depend on concrete classes. Does that make sense? Whenever we make a change or modify our code, we're gonna have to come back to this and make changes as well. So we don't want our code to be modifiable unless it's an absolute emergency. So this is the main motivation behind the factory pattern. We want an ability to create objects that adheres to the open close principle, allows us to program to an interface rather than to a concrete class, and to be able to construct many different kinds of objects in a way that is going to work with this. So it's similar to, but still very different from the builder. So another of the concepts, the OOP concepts that we've talked about, separate what varies from what stays the same. How can we answer a question in our code? What varies? As an example, we're going to look at a pizza shop. We're going to carry this pizza shop example all the way through both the factory and abstract factory patterns, because it's very useful for this, because pizza actually turns out to be a really good analogy. And once again, I'm talking about food at lunchtime. Can't help myself. I have not. Normally the coffee suppresses the hunger and I brewed myself some water. Oops. All right, here's a basic example of an order pizza method. We're going to instantiate a pizza object. And then we're going to, once we instantiate the pizza, we can figure out how to prepare, bake, cut, box the pizza before we return it, right? That's what an order would look like. We make the pizza object, that's kind of just throwing it all together, putting the ingredients on the dough, etc. That's not baking it or anything. We get back the pizza object, but it's not cooked or prepared for the order. So then we have to go through the preparation, the baking, the cutting, the boxing, and all of those are modifications to the pizza to prepare the pizza for delivery or handing to a customer or something of the sort. What are problems we see with this? Yeah, if anything changes about this, what happens? We have to go edit the code. We want the pizza constructor to be abstract of some kind. But we're programming directly to the implementation. So what happens when we want to extend it? We know there are multiple kinds of pizza, right? You instantiate a pizza and what everybody wants on their pizza is not the same. And the different styles of pizza are completely different. Like the East Coast kind of pizza is very different. The Midwest kind of pizza, which is very different from the West Coast kind of pizza, which is very different from signature Italian pizza, which is different from a Martian pizza, which is
No, pizza.
So one possibility to do this might look something like this. Now we're going to have a parameter in our order pizza that's going to tell us the information that we want on our pizza. And then we need to figure out what the type is of the pizza based on the parameter that is passed in. You could either order a cheese pizza or a Greek pizza or a pepperoni pizza. And here now you end up with those big if, else if kinds of blocks where you need to figure out at runtime what is the kind of pizza that the client wanted. So at runtime, we're going to be instantiating different subclasses of this pizza object based on what the user wants. No matter what they order, you prepare it, bake it, cut it, and box it the same way. So we don't need to put that in the constructor or anything else of the sort. We can just take whatever gets returned to us and do that associated logic. Since that would all be defined in the subclasses, even if there were differences, they'd be defined in the subclasses. So if we had a new pepperoni pizza that was still of type pizza, the instructions for preparing and baking and cutting that would all be in the pepperoni pizza subclass, which we would be able to call via polymorphism. Questions about this? We just talked about why this looks ugly. But at least now we can see how naturally you come to that type of code. We can further extend our pizza shop by adding new trendy pizza types. So here's what this would look like. This is a little bit small to see, so I'll zoom in on it. A little bit too far. Maybe not. So our old code was not closed for modification because now we have to go back and edit this whenever we come up with new kinds of pizza. So maybe the pizza shop across the street has now come up with new trendy pizzas, and we need to come up with new trendy pizzas to keep our customers coming back to us and keep them from going to them. So we would need to go back to our code and make all of these changes to our old code, which is not good. So we can see now, this is how we identify what changes. What subclasses are you going to be able to instantiate that varies based on the order received. On the other hand, these methods are the same for every object. Preparing, baking, cutting, and boxing pizza is the same regardless of what kind of pizza it is, assuming that there aren't different baking instructions for different kinds of pizza. Questions about this code? Why it's closed for modification? All right, so we need to figure out how we're going to encapsulate object creation. That's going to be the solution or a solution to this. We want to move the object creation out of this client code out of this order pizza method. And we want to be able to basically have a class that is defined for making pizza rather than a method that is defined for making pizza. So zooming in again. This is not yet a design pattern, but it is what we're going to call a simple factory. We pull the object creation code out of the method. So now instead of that big if-else block existing in that method, it's now going to go in its own class that we will call a simple pizza factory. The entire purpose of that class is just figuring out how do we make pizzas. So this is going to be a factory object. We're not at the factory pattern yet, but a factory object is again a constructor that has the benefits of a class rather than just the benefits of a method. So it's going to handle, I think that's what to say, handles all the details of object construction. What do we mean by this? What does the code look like? So here is a simple pizza factory. Just a little bit more. Good enough. Not good enough. There we go. So its entire purpose is just to make pizzas. We need a create pizza method within this class. And here we have our large if else block. Note that anywhere that is in the code that would have had to copy this if else if block now can just instantiate one of these pizza factory objects, and the if else block now only needs to be written once rather than all over the place. So we've made an improvement, which is good. It's still parameterized, which is good. So this is an improvement. Does everybody see the improvement? This code only lives in one place. There's only one gross block of code, and it's in its own class that can be referred to in any number of places. What's the benefit of this? We can call this from anywhere, any class, any method. We can create a new pizza factory object, and we can pass it. We can call its create pizza method to create an associated kind of pizza and pass it a string. So it's just like the constructor, except we actually have access to it, not just when an object is being created, but any time that we might want to make one of those objects. If modifications are needed, you modify this one piece of code and it will immediately propagate to any other function that calls or uses one of these objects. Right? So you don't need to go ask yourself, where are all of the places that I need to introduce a clam pizza or a veggie pizza as an option? There's only one place to make the change. Anyone who passes now a string to this create pizza method can now pass veggie, or clam to get their associated pizza. There's no way that you missed one of these somewhere in your code accidentally. There could be multiple different factory types. So you can make one of these classes for each kind of pizza style that we also might want to make. So we can make a factory object that makes New York pizzas and a factory object that makes Chicago pizzas. Because you can imagine there's a difference between the New York style cheese pizza and the Chicago style cheese pizza. So if we have different factory objects that can make each of these, we just instantiate the appropriate factory for the style of pizza that we want to make. Questions so far? So what does this look like? We have a factory class. What is a driver class or a client class of this? How do we interact with it? All right. So we can make a simple pizza factory object, right? This is just a reference to this object. We talked about how objects in memory work forever ago, basically in our review. When we make a simple pizza factory, what's actually happening in memory is we're making a reference. Oh, that is gross. You're dead. Can I actually hit this time? Yes. We're actually making a small pointer of an object that's eventually going to become a pizza factory object, but we haven't instantiated it yet. So all we're doing is creating a variable we're calling factory that points to a simple pizza factory object that doesn't exist yet. This is what the simple pizza factory object would be. So when we have this line, we're just making it. Great. So the pizza store now takes a factory as a parameter, and it's going to associate it with that. So basically, somewhere from the outside, we've produced a factory somehow, and when we pass it in as a parameter, it's going to say this factory, this Fields factory, is the factory that got passed in. So from somewhere, we're passing in this object, and now we're making an association with it. So now it's going to be this instantiated pizza factory that is this object here. Sure. So now order pizza is capable of, again, making a pizza object, which is going to be another object with a reference that we're going to call pizza. This has an arrow to no object yet, right? We haven't said equals new pizza or anything else to tell what this object is going to be. So right now it's just an empty unknown reference. Until we get to this line where we say pizza equals factory.create pizza. So this object embedded in it is going to know how to create a pizza. We identified what that looked like on the last slide. So somewhere in here, there is a create pizza method where we're going to say, okay, pizza equals this dot create pizza that's going to return an actual pizza object. We'll draw that as a circle because it's a pizza. So now this pizza is now pointing at this object that this object made. Great, now we have a pizza. Since we have the pizza object, we can prepare it, bake it, cut it, box it. And then after all of that work, we have a pizza in a box that we can return to whomever called this, interacted with this order pizza method. So it returns a pizza back from whence it came. If this second grade drawing doesn't get you excited, I don't know what will. Somehow I don't know, I've been teaching for 5+ years and still can't draw at more than a second grade level. But does that process make sense to people? So that's kind of what's happening with the code. There's some function in here that lets us make one of these. This is assigned as we enter this method. So this makes this box does everything that it needs and then returns it. So we no longer have a new operator in the create method, right? Nowhere in the create is there the keyword new. Sorry, not with a create method. So this does the actual creation for us, not the new keyword. And so it's the factory that's responsible for creating the object, not the new keyword. So we've replaced that idea with calling a method in a class rather than just a method. All right, so we call this a simple factory by itself, not a design pattern. This is very frequently used. This is if you ever need the concept of just a class constructor instead of a method constructor, because you have that large if block selecting multiple possible objects at runtime, you can abstract that into a single call in a simple factory. So here's the basic idea in its whole form. We can zoom in on that, right? Come on. There we go. Touchpads are the bane of my existence. I hate them. All right, so we have a pizza store. A pizza store can take an order. The order gets sent to the pizza factory. The pizza factory has a method called create pizza. When we create a pizza, we need to pass the kind of pizza so that the pizza generic superclass knows how to make a cheese pizza, a veggie pizza, a clam pizza, or a pepperoni pizza. When the simple pizza factory passes on, I want you to make one of these, it knows which one of these to call with their associated prepare, bake, cut, and box if there are any associated changes to this base instruction. Maybe the clam pizza needs to bake a little bit longer than the cheese pizza. That would be overridden in the clam pizza subclass. We would have some basic instructions for how to make a generic pizza here that apply to all of the subclasses. So now we are very happy with our single pizza store, except now we're so successful that we want a franchise. We want there to be multiple pizza stores, each of which have specializations. We actually want to incorporate the New York style pizza or the Chicago style pizza. So the factory pattern will have us producing multiple factories to be able to produce the associated kind of object. And here's where we go from an idea into a design pattern. So we have a pizza store, and a pizza store can have multiple factories associated with it. So we don't need to duplicate the pizza store code. All pizzas are prepared the same way. We'll pretend like they're prepared the same way. I mean, you still have to bake all the pizzas and cut all the pizzas and box all the pizzas. But the way you do that might be slightly different. But we want our pizza store code. So we can have multiple different factories, one of which makes a New York style pizza, one of which makes a Chicago style pizza. These can even now be different stores. Different stores can have access to different factories. You even have two stores next to each other, one of which is a New York pizza store and one of which is a Chicago pizza store, and they share an oven in the back. So we need different factories. We're going to have 3 of them. We'll have a New York pizza factory, a Chicago pizza factory, and why not, a California pizza factory. We then need to compose the pizza store with whatever factory is relevant for this. So what does this look like? When we make the pizza store, we're going to pass it a parameter. That parameter is going to be the instantiated factory. So we first make the New York pizza factory. That's capable of producing New York style pizzas. And then we will link that factory to our store. Think of it like linking the ovens to the actual store, to the cash register, something like that. We can also instantiate a Chicago pizza factory and make another pizza store that is instantiated or composed of a Chicago style factory. You can now order from either of these pizza stores the associated veggie pizza, and what you should get back would be a New York style veggie pizza or a Chicago style veggie pizza, depending on whether you ordered it from the New York store or the Chicago store that were instantiated with the appropriate factories. So far, so good? As usual in this class, there's some kind of downside to everything we talk about. What's the downside? What seems wrong about this code or not ideal about this code?
Would it be memory?
That's not too bad on memory. It's more of a design flaw. Who's doing this? Or this? Whose responsibility is it?
Fine.
The client. Who's the client? We don't know. Whoever is interfacing with this code needs to know how it works in order to be able to do it. That's the design flaw. We don't want the client to be able to mess something up. When you use a scanner, how many ways are there to misuse the scanner? There are tools, and you can use the tools, but you don't have to know how the tools work in order to use them. The client is coupling the factory with the store. That should already be done for us. The client should not have to worry about that. That is the answer.
Yeah, pizza store factory. One more level up.
Yep. This is how we get disgusting designs. So the client themselves needs to tie the store and the factory together. And when this happens, you can insert code into this process, right? Not all of these have to be done the same way. The client can do whatever they want here. And that's a little bit frightening. Treat the client like you would treat a baby who just can't seem to do anything except want to go drink poison. You need to keep an eye on them at all times. As soon as you're not looking at what they're doing, they're trying to kill themselves. You don't know what the client is doing. You need to encapsulate what you're doing so the client can't hurt themselves or you. So we're going to come up with a slightly different framework for this, but it's going to encapsulate that so that the client doesn't get the opportunity to pair these together incorrectly or insert some code into the pairing process that changes how it's done. So the goals for this, we still want all pizzas to be able to be made in the pizza store class. That stays the same. We want these franchises to be able to produce pizza in their preferred regional style still. That stays the same. So we want create pizza back in the pizza store. But it needs to be abstract because we don't know exactly how it's going to be created. Is it going to be created in New York style or Chicago style? We don't know that yet. But if the create pizza is abstract, then we can make our own inheritance hierarchy with regards to the pizza store and the kinds of pizzas that it produces. The subclasses of the abstract pizza store will be the New York pizza store or the Chicago pizza store that produce New York style pizzas or Chicago style pizzas. What does this look like? We'll make an abstract class with an order pizza method. We'll make a pizza. We'll instantiate that pizza by calling create pizza. And it needs to link the type that's passed in as a parameter so that that happens. It happens here rather than in the factory object. Everything else looks the same. So the entire factory method is now abstract and back in the pizza store. So now it's not its own separate class, it's its own, it's in the method. So it seems like we've undone some of the work that we've done, but let's see why this works better. We now have some subclasses to this. That's too much. Come back, come back. So the pizza store has an abstract create pizza method that is further defined in the New York style pizza store or the Chicago style pizza store. And it has an order pizza method that is the same for everything. The pizza store gets an order, it can delegate to the associated New York style pizza store or the Chicago style pizza store, depending on the information that it gets. This makes sense? So this is what create pizza looks like. The only thing that changes within these subclasses is the Chicago style or the New York style. So order pizza calls create pizza within the subclasses to actually get the pizza object, what kind of pizza it gets. The order pizza method doesn't know whether it's a New York style pizza or a Chicago style pizza. So these subclasses will decide which kind of pizza it produces, even though it's unknown at the order pizza stage, which is really interesting. So here's what the whole franchise store code will look like. We have a New York pizza store that is a subclass of the pizza store. We have a create pizza method that takes some description, what kind of pizza you want. We then have our big if block that says if the request is for a cheese pizza, we will return a New York style cheese pizza. If the request is for a veggie pizza, we will return a New York style veggie pizza. So this is where we figure out where those concrete classes are going to be. It's where we figure out exactly what kind of pizza we're creating. It's in the subclass of this whole thing. This star down at the bottom is reasonably important. The order pizza method in the superclass has no idea what it's working with. It does not know which pizza it's creating. It just knows that it's delegating to either the New York pizza store or the Chicago pizza store, such that we can analyze this parameter that's passed in to figure out what kind of pizza we're making. That's something that could probably be fairly easily confused. So the way we did this in the past, we had some object outside of everything that handled the instantiation of all of the concrete classes. What we just discussed is we're going to make an inheritance hierarchy, and the subclasses of the pizza store now handle the responsibility that the simple factory object used to do for us. The general takeaway if you have what we call a factory method, which is what we did with the create pizza within the subclasses, it's going to handle object creation, and it's also encapsulated in that subclass, which means that it can't be messed with at all. It can't be modified by the client. That's what we mean by it's encapsulated in the subclass. The only thing that can create the pizza is the subclass itself. So you need to interact with it in such a way that the subclass creates that pizza. Now the user can't directly request that and skip over the factory. It has to interact with the factory in order to make the associated pizza. This is great. The client code is now separate from the pizza store. And all of the creation code that is in all of the New York style pizza store, Chicago style pizza store, etc. The client is now separate from this. The client doesn't call create directly. The client doesn't make the pizza itself. The client doesn't make the factory itself. It's all done with a single call to the factory object, the superclass pizza store. Basically, you put in the order and it delegates to create the appropriate pizza. So this is better than our last implementation for that reason. So that's what the general method looks like. And here's the code in diagram. So we have an abstract pizza store with an abstract ordering of pizza. We just create the pizza from that superclass without knowing what type it is. Once it's done, it'll use the appropriate subclass to create that. We can prepare it, bake it, cut it, box it, and return it. Questions about this? All right, so what happens? From the user's perspective, we're going to abstract now out of the code itself, and we are going to walk into this code and order a pizza. In fact, we're going to call ourselves Ethan. We are hungry, and we want to order a New York style pizza. We have a friend named Joel, also hungry, wants to order a Chicago style pizza. Both of them need their own separate pizza store, right? Since a New York pizza is not the same as a Chicago pizza, they're going to have different pizza stores to be able to make the New York style pizza or the Chicago style pizza. Ethan needs to go to a New York pizza store. Joel needs to go to a Chicago pizza store. Once they have that object, they're in the store, they're going to call the order pizza method, which is that abstract superclass. But since they're in a New York pizza store or a Chicago pizza store, the order pizza will direct them to the New York instantiation or the Chicago instantiation because that's the object type that they're in or dealing with. So they pass the type of pizza. The order pizza just passes the type of pizza. It's the same order pizza method for both. When I say I'd like a cheese pizza, the only thing that needs to change is the actual baking of the making of the pizza in the New York style or the Chicago style. If the waiter in the two different restaurants doesn't need to take the knowledge of this is a New York style cheese pizza or this is a Chicago style cheese pizza because you're in the restaurant for the New York style or the restaurant for the Chicago style. So if the waiter still just takes a ticket that says cheese pizza back to be cooked, the cook knows if I'm in a New York style pizza restaurant, I should cook a New York style cheese pizza. If I'm in the Chicago style restaurant, I should cook a Chicago style cheese pizza. So that's why the waiter doesn't need to know, or the order pizza method doesn't need to know. You can think of that kind of like the waiter. Last piece for this, you can think of there being a single place where these get baked in the bag. When an order from the New York pizza store is received, it goes through the steps to create a New York style pizza. When an order from the Chicago pizza store is received, it goes through the steps to create a Chicago style pizza. The completed pizza is passed back via the order pizza method back to the appropriate store. And the order pizza method, again, doesn't need to know where that is. They just go back to the oven to get the thing, the ticket that they handed in. Order pizza has no idea what kind of pizza was created. It just knows it's a pizza. All pizzas are cut and boxed the same way, so it knows how to do that. We'll come back to this next week. I think we're planning to do something a little bit more fun tomorrow. But we'll come back to this next week and finish off the factory pattern and learn about abstract factory, which takes this concept and abstracts it even further. See you then.